Hey guys, my name is Brandon, and today we're going to talk about discrete probability distributions. So the first thing I wanted to describe to you guys is what a discrete random variable is. A discrete random variable is a number that we don't know exactly, so we represent it with the letter x. What we do know is that it has a probability of equaling certain values and zero probability of equaling other values. To organize the values that it is allowed to equal, we use index notation. For example, x sub 1 could be one value, x sub 2 could be another value, and so on. To summarize all these values that x is allowed to equal, we say that x has some probability of equaling x sub I, where I is equal to 1, 2, 3, all the way up to the total number of values x is allowed to equal. To find the corresponding probabilities that x is allowed to equal, we use a probability distribution function p. Any value that we want to find the corresponding probability for, we just plug that into our function p. In other words, the probability of x equaling a certain value x sub I is equal to p of x sub I. For example, your discrete random variable could represent the number that you get when you roll dice. And the values that x sub I is allowed to take on are the numbers 1 through 6 because these are all the possible numbers you can get when you roll the dice. The probability of x equaling x sub I is equal to 1/6. This is because we assume all the possible outcomes are equally likely to occur. In other words, the probability distribution function evaluated at 1, 2, 3, 4, 5, or 6 is always 1/6, but the probability distribution function evaluated at any other value is always going to be 0 because you can't get any other number besides the numbers 1 through 6 when you roll the dice. With that being said, if we sum together all the corresponding probabilities for the values that x sub I is allowed to take on, then we should get 1. This implies that the probability of getting one of those values is 100%. Let's move on to an example. In this example, it says let x be a discrete random variable that can take on the value 0 with a probability of 0.25, a value of 0.1 with a probability of 0.4, a value of 0.2 with a probability of 0.05, or a value of 0.3 with a probability of 0.3. Does the sum of all the probabilities add up to 1? What are the chances that x equals 0.12? What are the chances that x equals the value 0.1 or 0.2? To answer the first question, we sum together all the corresponding probabilities of x sub I, where I is equal to numbers 1 through 4 because there are only 4 possible values that x can take on. And as you can see, it does end up being 1. Because the sum of all these given probabilities adds up to 1, we know that we're considering all the possible outcomes. So the probability of x equaling 0.12 is 0. Moving on, if we wanted to know the probability for x equaling 0.1 or 0.2, we just sum together those two corresponding probabilities, and that ends up equaling 0.45. In other words, the chance of x equaling 0.1 or 0.2 is 45%. So next I wanted to describe to you guys what the mean is. It's defined as the summation of the products of all the possible values with their corresponding probabilities. Mathematically, this is expressed as a summation over all the ith indices of x sub I times p of x sub I, which is equal to x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2, all the way up to x sub n times p of x sub n, where n is the total number of values that x is allowed to equal. The mean is sometimes referred to as the average value or expectation value. But be careful with the name expectation value. That sounds like when you go to make the measurement, that's the value you're going to be getting because that's what you're expecting. That would be the most probable value, or the value with the highest probability of occurring, which can be very far from the average value. So don't be misled by the name expectation value. Furthermore, in some chemistry books or statistics books, you may see the mean defined as E of x or x bar. In this video, of course, we're going to be defining the mean using pointy brackets. Next, we're going to define what the mean squared is, and that's the summation of the products of all the possible values squared and their corresponding probabilities. Mathematically, this is expressed as a summation over all the ith indices of x sub I squared times p of x sub I, which is equal to x sub 1 squared times p of x sub 1 plus x sub 2 squared times p of x sub 2, all the way up to x sub n squared times p of x sub n. And it turns out that we can actually calculate the average value of any function of x as long as we're given the probability distribution for x. Mathematically speaking, we can express this as a summation over all the ith indices of f of x sub I times p of x sub I, which is equal to f of x sub 1 times p of x sub 1 plus f of x sub 2 times p of x sub 2, all the way up to f of x sub n times p of x sub n, where n is the total number of values that x is allowed to equal. So in this example, they're saying let x be a discrete random variable. It could take on the value 3 with a probability of 0.2, the value of 6 with a probability of 0.4, or the value of 9 with a probability of 0.4. If the discrete random variable y is defined as y equaling x squared minus 3x, find the average value of y. So because y is a function of x, and we're given the probability distribution function for x, we can calculate the average value of y. Using the equation from the previous slide, we find that this is equal to the summation over all the ith indices of y of x sub I times p of x sub I, which is equal to 28.8. And so today you guys learned about discrete probability distributions, discrete random variables, and how to calculate the average value of any function of those discrete random variables. Thank you very much for watching my video, and please subscribe.